So I can write this as n plus 4 factorial. That means it will be running from up to n plus 4 factorial divided by n factorial. So it's a shortened notation of that. Okay, now let's find out the next term, which is n plus 2. The terms corresponds to a dagger square terms. So a dagger square here, this is a square. This is not having any particular, a dagger and a both are there. So yeah, a dagger square terms, one is this a dagger square into 1 plus 2 a dagger a, and also this term. So these are the two terms which are having an a dagger square operation. So we have to put that operator and find out the corresponding value. So we have a dagger square into 1 plus 2 a dagger a. That's it, right? That is one term. Plus one more term is there, which is starting with 1 plus 2 a dagger a multiplied with the a dagger square. Both of them are at different order, so the value, whatever n value you are getting, is not going to be the same. So, n, this is something that we have to find out. Again, here you can see, you can multiply the terms and reduce the overall expansion a little bit by using the property like a dagger is equal to a dagger a minus a dagger, which is equal to 1. So a dagger a, you can substitute 1 plus a dagger and reduce this overall expansion a little bit, and you can do that. So that will give you the term, the entire term n plus 2. The overall term, all this operation will become 2 times a dagger cube a plus a dagger cube. With n, right? Okay, this is how it comes. Now you can directly put the values. First, this a dagger cube acting on n, or you can put first term here. So n plus 2 a acting on n produces something like, okay, 2 is there on the first term which is coming out, and also there will be the state corresponding to that, n plus 2 at the end of everything it will produce, which is going to be 1. Okay, what else is there? Root n, and the state became n minus 1 now, and from the n minus 1, this is actually making n minus 1 to n. That time it will produce a root 1, and also n plus 1, and next is n plus 2, right? N plus 2. So that is the first term. Okay, this is 1, so I'm not using that. Next term is n plus 2, this quantity. So what if a dagger acting on a, it will produce root n plus 1 and root n plus 2, and one more time, so root n plus 3, and then bringing down by 1 state. So n plus 3 to n plus 1, AE acting on that operation, it will produce n plus 3. Okay, so just reducing that term will give you what we require. So this is actually 2 n root n plus 1 into n plus 2. So 2 is common here. Okay, 2 is there in this case also, so I'll take 2 common. 2 and root n plus 1, root n plus 2, both are common, so I'll take all together root n plus 1, root n plus 2, and what is remaining here in the first term is nothing but n, right? N plus here n plus 1 and n plus 2 is taken, n plus 3, so this is again 2n plus 3 into 2, right? So this is 2 into 2n plus 3 root n plus 1 into root n plus 2, or you can write it like 2 into 2n plus 3 root of n plus 2 factorial divided by n factorial inside root. That is our quantity, the second term, and exactly the same way you have to proceed with another 2 components. I am not doing that. So next term is note that we don't have n corresponding to n, we don't have a term. Next one will come n minus 2 n. So n minus 2, the operation corresponds to that into n. The operation corresponds to that is actually a square 1 plus 2a dagger a. This will be one term, and the opposite of that will be the second term, that is 1 plus 2a dagger a into a square operator acting on n. So this is a 2 terms, and you do the exactly same procedure, and finally you will end up with the result which is 2 into 2n minus 1, and here you will be having n factorial divided by n minus 2 factorial. There is nothing different, everything is similar procedure. So finally you will get something like this. Okay, so what we wanted to find out, individual terms already we got, and to get the correction in the wave function we need one more quantity. For each of the states we need we found out the numerator. Now we need to find out the denominator, which is change in the energy between the states whatever you have taken. So here okay, we can directly put it in the expression. So I'll put my psi n1. So expression for psi n1 is one c factor was there, along with that h cross omega by what else, one k square was there, and 2 whole square, and what we have to find out extra is m not equal to n, this quantity which is m, the operation corresponds to x cap raised to 4. Completely there. that is a plus a dagger whole raised to 4 n divided by en0 minus em0 into this m, whichever state it is. Okay, so we already got the states and this value also we obtained. What we need to find out is individual states, what is the energy difference. So between okay, we can directly put the value. So this is going to be c h cross omega square divided by 2k square, that is a constant, and the first term which is coming is from the n plus 4 n plus 4 term, right? So that corresponds to a state n plus 4. Okay, just write the number whatever we got. So this is nothing but first term which is root n plus 4 factorial by n factorial, root n plus 4 factorial divided by n factorial is the first term, which corresponds to a state n plus m, so m plus n plus 4 plus 4. That is the first one, and second one is corresponding to the n plus 2 state, which is 2 times 2n plus 3 into similar term like okay n plus 2 factorial divided by n factorial, n plus 2 factorial divided by n factorial, and which corresponds to n plus 2 plus next term is into 2n minus 1, right? 2 into 2n minus 1 root, I think it is n factorial divided by n minus 2 factorial, and the state is n minus 2 plus the fourth one, which is going to be similar to the first term. Difference is that n factorial will be coming on top, n factorial divided by n minus 4 factorial, which corresponds to n minus 4. So these are the different components which are coming in our correction. Okay, so yeah, along with that we didn't put the energy value here, we have to put the energy. So between energy level n plus 4 and the first term corresponds to n plus 4 and n is equal to 0 kind of. So what is the energy difference between those two states, E and 0? So here m is okay, you can write it E n 0 is equal to n plus half h cross omega. E m 0 is nothing but m plus half h cross omega. What we need to find out is En0 minus Em0, right? En0 minus Em0. Okay, so that is nothing but n minus m h cross omega. So the first case, the difference between n and m is 4, so this will become 4 h cross omega. You will be having n plus 4 here, and okay, sorry, for the first term m is equal to n plus 4, so that will be minus minus 4 h cross omega for the first term, minus 4 h cross omega. For the second term it is minus 2 h cross omega. First term it is h cross omega, and then it will become, sorry, h cross, not 2 h cross omega, and finally it will become 4 h cross omega. Okay, so these two terms are going to be positive, and the another two terms are going to be negative. So we'll write in that order. So the entire equation will become ch cross omega square by this 2 square is there, okay, 2 square, this is also having square, 2 square. So this square terms you can put together. I'm putting the constants here, ch cross omega square and divided by k square. Inside the bracket I'll just write the positive term first. This is positive, and what else is there? In the denominator we have 4 h cross omega. So h cross omega is there in all the term which is coming as the difference in energy. So 1 h cross omega you can cancel from here with the denominator, so only 1 h cross omega will be remaining, and remaining things are nothing but 1 by 2 square is there here, and also 1 4 factor is coming, which is nothing but 1 by 2 raised to 4. And to get the standard form of the expression, 1 by 2 raised to 4, I'm just modifying. 1 by 2 raised to 4, and what else is there? Root and factorial is there, divided by n minus 4 factorial into n minus 4. That is the state. Okay, next one is n minus 2, where we have 2 into 2n minus 1 divided by 2 h cross omega. So those two are cancelled, and this 2 square will be coming down. So 1 by 2 raised to 2, and what else is there? Is nothing but root n factorial divided by, okay, one more term is there. You have 2n minus 1, 2n minus 1 by 2 square into root n factorial divided by n minus 2 factorial. Okay, another two terms. First one is of the similar form, and exactly the same thing will happen for that. Only the thing is that 2n plus 3 is the coefficient coming here, and 2 raised to 2. This 2 raised to 2 will be coming inside, which is 2 raised to 2, and another 2 will be cancelling, and this will be n plus 2 factorial divided by n factorial. State is nothing but n plus 2. This is not plus, it's minus. Okay. This is minus, and the last term is again minus, which is having minus 4h cross omega. So again it's 1 by 2 raised to 4 root n plus 4 factorial by n factorial. Okay, so I think we have done n plus 4. Okay, so that is a final form of the expression, first order correction in wave function. The entire wave function can be written as psi n. It is psi n is equal to phi n, or what's our unperturbed component, along with that first order correction psi n 1, lambda is 1 here. Okay, so that is nothing but phi n plus whatever we obtained right now is something like c h cross omega divided by k square into 1 by 2 raised to 4 root n factorial divided by n minus 4 factorial n minus 4 plus exactly the same term. That's it. Two n minus 1 divided by 2 raised to 2 root n factorial divided by n minus 2 factorial into, okay, I haven't written the state there, that is n minus 2 plus or minus 2n plus 3 divided by 2 square root n plus 2 factorial divided by n factorial and n plus 2. That is n plus 2 state, and finally the last term. That is 1 by 2 raised to 4 root n plus 4 factorial divided by n factorial and nothing else, n plus 4. Okay, this is minus. How to delete it? Okay, so this is the wave function, the complete wave function of first order correction. Okay, so this is how we are doing the harmonic oscillator problem and anharmonic oscillator using our perturbation analysis. And we have some easy examples, and I will show you. Okay, I will give you the problems on Friday, and you have to do it and get familiar with the analysis. And by that we are almost done with our non degenerate perturbation theory, and we have to get into the degenerate perturbation theory next class. Okay.